Hello everyone. Today in this video we are going to discuss the solution of a specimen paper 1 of higher level mathematics analysis and approaches. And in this paper 1 GDC is not allowed, so we'll be doing without GDC, but if in case it is required to show the scenario, I will use the GDC. And it is of 110 marks and for 2 hours. So let's start the questions. So this is the question number 1 in section A. It's of 5 marks. Let A and B be events such that probability of event A is 0.5, probability of event B is 0.4, and probability of A union B is 0.6, and we need to find probability of A given B. So it's a conditional probability. From the formula booklet we can get the formula for conditional probability A given B, and that is probability of A given B as P of A intersection B over P of B. And if you see the question, we have P of A union B. So first of all we need to find the A probability of A intersection B, which is going to be done by the help of additional law of probability. And additional law of probability says that if we are finding A intersection B, then it is going to be probability of A plus probability of B minus probability of A union B, means it become 0.5, it is given, 0.4 it is given, minus 0.6 it is given, and this become 0.3. So here from this we get the probability of A given B as 0.3 over 0.4, which is 3 over 4, or in the decimal we can write it as 0.75. So that's the probability of A given B. So now we have the second question. A part, show that 2n minus 1 whole square plus 2n plus 1 whole square is 8n square plus 2, where n belongs to Z. So we are going to prove this as, we'll start from left hand side and we'll equate it to the right hand side. So left hand side is A part, left hand side is 2n minus 1 whole square plus 2n plus 1 whole square, and if you open the bracket it is going to be 4n square minus 4n plus 1 and 4n square plus 4n plus 1. So minus 4n plus 4n got cancelled and we got 2n square plus 2, and which is, we can see it is right hand side, hence proved. In the B part it says, hence or otherwise prove that the sum of the squares of any two consecutive odd integer is even. So here we can see in the A part, if we see 2 and for any n belongs to Z, 2n minus 1 is going to be odd, and next odd number, next consecutive odd number would be 2n plus 1. This is also going to be odd number. And so from A part we have seen that sum of the square means 2n minus 1 whole square plus 2n plus 1 square is 8n square plus 2. And we can rewrite this thing, we can take 2 common, then it becomes 4n square plus 1. Now for any n belongs to integer, 4n square plus 1 doesn't matter what is it, but if we multiply by 2, this is always going to be even number. So we can write that sum of the squares of any two consecutive odd integer is going to be even number. And in question number 3, let f dash x be 8x over root 2x plus 1, Given that f of 0 is 0, f of 0 is 5, and then we need to find fx. So from here we can understand that if the first derivative is given and you need to find the function, it means we are going to do the integration. So we can directly write fx equals integration of this function f 8x over 2x squared plus 1 dx. And here if you see the term in the square root, which is 2x squared plus 1, its derivative is going to be 4x, means linear, and that is given, linear polynomial is given in the numerator. So we are going to take this term as u, means integration by substitution. So this du over dx will become 4x, and from here we can write du equals 4x dx, or we can write 2 du equals 8x dx, just to substitute everything. From here we got 8x dx to be substituted as 2 du and 2x squared plus 1 by u. So this whole thing become 1 over root u and then du, and 2 times here, so 2 is a constant, we can write it here 2. So 8x dx become 2 du and root 2x squared plus 1 become root u, and now we can do the integration. So we can transfer it in the numerator. It is going to be u to the power negative half, 2 is a constant outside, and then we will integrate it. So 2, then u to the power negative half plus 1 is positive half, and divide by positive half means multiply by 2. So this is the condition, this is the integration, and then plus c. So finally we got fx as 4 square root of u power half means square root of u, and we will substitute back in the terms of x, so it becomes 2x squared plus 1 plus c. Now it is given that f of 0 is 5. So f of 0 is 5. From here it is going to be 4 times root 0 plus 1 is simply 1 plus c, means c become 5 minus 4, which is 1. So ultimately we got fx, which we need to find. Fx equals to 4 root 2x squared plus 1 plus 1 outside. So that's the fx, 4 root of 2x squared plus 1 plus 1. I hope it's clear. In the question number 4, the following diagram shows the graph of y equals fx. The graph has a horizontal asymptote at y equals minus 1. The graph crosses the x-axis at x equals minus 1 and x equals 1, and the y-axis at y equals 2. So these are the information given about the graph, we can see. So the question is, on the following set of axes, sketch the graph of y equals fx square plus 1, clearly showing any asymptote with their equations and coordinates of any local minima or maxima point. So initially we'll see what all thing will happen in the original graph, and then we'll sketch it on the different axis. So first of all, it is fx square. So wherever we have y, fx means y, original y, y will square it, and then we are going to add 1. So if we choose y-intercept, which was 2, so squaring 2 is going to be 4, and plus 1, that is going to be 5. So this particular point will go to 5 on the y-axis. If we see the x-intercept, it is y is 0 because it is 1 comma 0. So squaring 0 is again going to give you 0. Then plus 1, this point will go here, means in place of x-intercept, now this is going to touch here. Why touch? Because if it is square, this particular portion will go up. So This is the first one, and then again -1, again -1. For -1 comma 0, again it is going to be at 1 because squaring the 0 is 0, plus 1 will transfer this point here. So and lastly it is asymptote. Earlier the asymptote is -1, so again here also you'll do the square. So squaring -1 is going to give you 1, and if you add 1, so it becomes 2. So ultimately we got asymptote at y equals 2. So these things we got, and then we'll draw the graph on the different sets here. So first of all we'll draw the asymptote. It is at y equals 2. This is going to be the asymptote, and y-intercept was 5 x, and then these 2 points were the originally it was x-intercept, now it is going to be here. And when we know that when square happens, this got shrinked every time. So you can say that this graph will be like, it is going to touch this point going above till 5 and coming back. It has to be symmetric, this, and then asymptote. So for asymptote it is going to be here, and then it will go till this one. So this is the graph of new equation, y equals to fx whole square plus 1. So these points we should mark. It is 1 comma 1, this is -1 comma 1, this is 5, and this point is, this line is y equals 2, to make sure that everything is visible, all the information about the graph is visible. So that's the answer. Now the question number 5, the functions f and g are defined such that fx equals x plus 3 over 4 and gx equals 8x plus 5. So both of them are line, we can see. So first part is show that GOF of x is 2x plus 1. So it's a composite function, and we know whenever we have the composite function, if we rewrite this thing once again, it would be more clear. Like I mean, if we have GOF of x, we can rewrite this thing as G of f of x. Means now the fx is the input for gx. So fx, we can rewrite fx, we have x plus 3 over 4, and now in place of this x we got input as x plus 3 over 4, and gx has the property that it multiply 8 to its input and then add 5. So you got 8 times x plus 3 over 4 plus 5. So we can cancel these two, and then it become 2x plus 6 because we multiply in both the terms, and then plus 5, which will give us our answer 2x plus 11, and hence it is proved. And in the B part, given that GOF of inverse of G of f a is 4, find the value of a. So in the B part we can see that this function, the original function GOF of x equals to x plus 1, it's a line. It's a line with gradient 2. So this line is going to be something like this. So it means it is going to be 1 to 1, 1 to 1. So if it is 1 to 1 means it is we can find the inverse, and the inverse of a line is again a line. We can write from this information as a as GOF of 4. So we can get it as 2 times 4 plus 11, which is 8 plus 11 means 19. So a become 19. Had it been a quadratic equation, we could not do that. In that case, we have to first of all find the inverse function, and then we have to substitute the a value and then get the 4 as the final answer. For example, if we have this, it is not 1 to 1, we can see by horizontal line test. So if it is not 1 to 1, we cannot find the inverse directly. because there is going the inverse. If we take the reflection of it from the y equals x line, it will give you a curve which is not a function. So basically whenever we have the linear equation, we can always do this. I hope it is clear. Now question number 6, show that log cos 2x plus 2 base 9 equals log root cos 2x plus 2 base 3. So we can see we are going to change the base of the log. So first of all we will write and we are going to make the new base as 3. So we will write the left hand side as log cos 2x plus 2 base 3 over log 9 base 3, because the formula is if we write log a base b, we can write it as log a over log b including a new base c. We can write like this, and then we know another identity like log a to the power n a is going to be simply n, and hence we got it as 1 upon 2, because 9 is 3 square, log base 3 cos 2x plus 2, and we know multiplication goes to the power in the log case, so it becomes log of cos 2x plus 2 base 3, and whole to the power 1 by 2 we can write it as square root. So we are using these three properties. Log a to the power n base b is n log a base b. We have used these properties and we got this answer. It is the right hand side. Now for the b part, hence or otherwise solve log 2 sin x base 3 equals log cos 2x plus 2 base 9 for x in between 0 to pi by 2. So we are going to use the result. We are going to solve by hence, means we have the result y to go like this. The left hand side will not do anything. This is going to be 2 sin x, and from this first part we have seen this is same as root cos 2x plus 2 base 3, so it becomes log square root of cos 2x plus 2, and log is a monotonic function. We can directly write we should not cut log, but we can write directly 2 sin x equals root cos 2x plus 2. Then we'll square both the side. We'll get 4 sine square x equals removing the square root. We got this, and from here we can see we have sine square x on the left hand side, and cos 2x has 3 identities. We can check from the formula booklet, it is given there as well. So cos 2x will use the third identity, which includes the sine. So this will become 4 sine square x equals 1 minus 2 sine square x plus 2. So if you take all the things one side, or just sine square term one side, we will get 6 sine square x equals 3, means sine square x equals 1 over 2, or we can say sine x equals plus minus root 1 over 2. So from here we can see sine x is either going to be 1 over root 2, or sine x is going to be negative of 1 over root 2, but we are finding x between 0 and x is lying between 0 and pi by 2. 0 and pi by 2, it means in the first quadrant sine is always positive, so we cannot take this, it's not possible. So we'll only take sine x equals 1 by root 2, and we know it is going to be sine inverse 1 by root 2, or we can directly write it is going to be pi by 4. So x is pi by 4, and here we can write not possible. Why? Because in first quadrant sign is going to be always positive. Now question number 7. A continuous random variable x has the probability density function f given by fx equals pi x over 36 sine pi x over 6 in 0 and 0 to 6, and otherwise it is 0. We need to find probability of x greater than or equals to 0 and less than or equals to 3. So it is a continuous random variable. In continuous random variable we know the probability between two values. Here in the case of 0 and 3, it is going to be the integration of fx between 0 from 0 to 3 dx, and here we have the values. So 0 to 3 fx is pi x over 36. So pi over 36 is a constant. I will keep it outside, and then it is x sine pi x over 6 dx. Now we will integrate it. We can see there are two functions together. One is sine x, another is x, so we can use the integration by part. We'll take first function as u, which is x, and for second function dv over dx we can take it as sine pi x over 6. So from here we got du over dx, or u dash equals x 1, and from here v become minus, because integration of sine pi x over 6 is negative, cos pi x over 6, and we'll divide by the coefficient of x, so it is going to be 6 over pi. So we got this, and now we are going to use the integration by part. And integration by part is, first you will write u into v, so it is negative 6 over pi. I'm keeping this pi over 36 for now, or I should multiply it. Let's make it a continuous thing. It is the probability, and then 6 over pi, and it is x because u, and then cos of pi x over 6 it is, and then we will put the limits from 0 to 3 afterward, minus integration of differentiation of first function, and differentiation of first function we can see it is going to be 1. We have seen this is 1, and integration of second, so it is going to be minus, so negative and negative become positive, 6 over pi, and then this cos of pi x over 6 dx. And now we'll close the bracket, so we can rewrite this thing as pi over 36, and then we can put the values here. Upper limit is 3, so upper limit is 3, it means minus 6 3s are 18 over pi cos pi into 3 over 6 pi by 2, cos pi by 2 become 0, so it is multiplied by 0, minus, so minus again minus 6 pi by 6 over pi into 0 is going to be 0, so ultimately this becomes 0. So we only have to find the integration of this from 0 to 3. Sorry, I did not mention it here, and then it is going to be plus 6 over pi as such, and different integration of cos pi by 6x is going to be 6 over pi sine pi x over 6, and then the limits from 0 to 3 and closing the bracket, and then finally we got pi over 36 multiplied by 36 over pi, and the limit cos from for 3 sine pi by 2 minus sine 0, so it become it is pi squared, 36 got cancelled, pi got cancelled, so sine pi by 2 is 1, so ultimately we got it as 1 over pi. That's the probability of x between 0 and 3. So that's it for this video. We will discuss the rest of the question in next video. Till then, thank you so much.